Today, I want to share with you how to build an air predictive model for air pollution. But before I dive into my presentation, a really quick introduction about who I am. I'm Stefan Angelov, and I have background in economics and healthcare, in particular sunlight therapy and air purifying systems. So my motivation for the project stems from the fact that air pollution can cause a lot of horrible diseases if not caught early enough and slowly damage the lungs and cardiovascular system. The main question I originally set out to ask was, could I somehow take the extremely important elements that can predict the upcoming changes in the air quality, and can data science and machine learning help us predict what are the next day or even months pollution will be? I conducted expository data analysis. The dataset considers 6 main air pollutants and 6 relevant meteorological variables collected at the outdoor stations across Beijing. It covers the daily data for 5 years between the years 2013 and 17. If we take a closer look, we could observe that all of the stations look pretty similar. There is the same pattern. Because of that, I decided to predict the air pollution for only one of them. After cleaning and interpreting the data, I resampled into daily by taking the average of hours and monthly by taking monthly average of maximum value in a day. I broke the data into 3/4 train test split, which means that the first 3 years are for train and the last 1 year for testing the model and see how it performed. I've decided to build few LSTM models, which stands for long short-term memory network, and it works extremely well to the time series data. Here you can see the daily prediction, and it seems that predicting very well for the first few weeks. If we take a closer look at O3, we can see that the model picked the upcoming trend and it predicts quite accurate the first 3 weeks. After that, I've decided to build another model for monthly prediction. On the slides, you can see LSTM many-to-many model, where the input is 6 of the pollutants elements and the output is the same 6. For SO2, it predicts very well, but for the PM2.5 and PM10, it doesn't. It seems to predict very well when there is a clear seasonal pattern. If we look at SO2, there is a clear peak once a year, and it seems to go slightly less each year. It starts big 2014 and it lasts 2015, and it predicted correctly for 2016 and 17. It's relatively good at CO and over-predicted a little bit. Interestingly enough, the prediction looks like it should be correct. There is a little bit of a peak at 2014 and 15, and an even bigger peak in 2016. So predicted an even bigger peak in 2017, but it wasn't. It's doing very good on O3. As we can see, there is a clear seasonal pattern and predicted well. The measure of success of this kind of model, it's RMSE, root mean square error, which we want to be as small as possible because it measures the variance between what you predict and how the model actually performed. In summary, the model is predicting very well NO2, SO2, and O3. The reason why it's not predicting well the others, it's because the hyperparameters work very well for some, but not for the others. Future development will be to try other features or time steps, build 6 different one-to-one models or other models entirely. Include the weather data, because the weather is highly correlated with pollution. Also, higher pressure correlates with higher amount of pollution. Thank you so much for your attention.